So this video discusses about what we call as the multivariable functions. So what are the multivariable functions? As the name itself suggests, if we say multivariable functions, these are the functions with more than a single variable. We can have, the functions of 2 variables, the functions of 3 variables, or even more than that. So that is how you used to have to understand about the multivariable functions. But before we go for the multivariable functions, let's have something about univariable functions. So univariable functions, they are also said to be monovariable functions. These are the functions with actually a single variable, and they are also said to be the single variable functions. So let's consider the system that represents the univariable function. Let's say we have the system. There should be something about this. Let's say we have the system that is presenting the univariable system. It should be univariable function. Let's say the system, it is the system of the function given as f. Let me use that. Let's say it is the system of the function given as f. And we have the input of the system. And we have the input of the system that are called as, let's say, given as actual x. Let's say the input is given as x. And now for this case, the output, it is given as f of x. So that is the output, which is the same as y. So according to the definition of the function, now the function of this particular univariable function, this particular univariable, it is given as f of x is equal to y, where x is the input. So which means we can have, let's say, f of x, being given as, let's say, 5x. F of x, let's say, being given as, let's say, 6x minus 2. These are the examples of the univariable functions. So those are the functions of the single variables. And what is that single variable? It is the input. Let's say we can have, let's say, f of x, let's say x squared minus 2x plus 1. We can have that. And let's say if we have f of m, negative 2m squared plus, let's say, 6m, we can have that. And let's say f of, let's say, y, which is equal to, that should be ym, should be that, let's say ym plus, let's say, y to the power 4 can be that. And assuming that m, it is a constant, as it is there, it means input, it is given as y. So in that case, that is, you can have also some sort of the examples of the univariable functions. That is, let's say f of x is equal, let's say, you can have it as negative 6x to the power 5 minus 1. You can have that. And let's say f of, let's say, x, and which is equal to, let's say, 3m squared and plus 7m can be that. So those are the examples of the univariable functions. And we can also have in terms of, let's say, y is equal, let's say, x plus 2, much as y, it is the same as having it as f of x. So keep that in mind. And how about the actually multivariable functions? And let's consider the system. Let's say we have the system of the function f of x, should be f. And let's say we have the 2 inputs. That is, we have the input as, let's say, x, and we have the input that are called as, should be y. And now the output of the system will be given as f of, since the 2 variables are inputs, it means we'll have f of x comma y, and which is also be expressed as actually given as z. So in this case, according to the principles behind the definition, we'll have it as f of x, y being given as, z, where z is the output of the function. Now in this case, this is the function of 2 variables. So what are the examples we can have? We can have f of x comma y is equal to, let's say, x squared minus y. You can have that. And let's say you can have f of xy, let's say, is equal to negative x squared and plus, let's say, 2y. You can have that. And let's say if we can have something about, let's say, we can have examples like f of, let's say, xy is equal to, should be 4xy. It can be that. We can have, let's say, g of xy which is equal to 4 y squared minus, let's say, 6x. You can have that. And also you can also have, let's say, h of mn, so which is the same as, let's say, should be 10mn minus, let's say, 6mn. You can have that. Should be square, rather, should have that. And what are the other examples of the variables of the functions with the two variables? We can have, let's say, should be k of, let's say, x comma y. Can be that, which is the same as, should be 6x squared minus y squared. We can have that. And then if we can have, let's say, f of xy, which is the same as, let's say, sine x squared and y squared. So we have different examples of the multivariable, actually, functions of two variables that you should have to get. And how about the functions with three variables? And also, let's consider the same system. Let's say we have the system where we have, three inputs. And let's say we have the input given as x, and we have the input given as, let's say, should be y, and we have the input, let's say, given as the should be z. And now for this case, we have the system of the function f. So now the output will be given as f of x, y, z. That is the same as w. So according to the principle behind the definition, we'll have it as fx y w is equal to z, where z is the output. So in this case, the examples of the functions with three variables, we can have, let's say, f of xy, w can be given as 2x, should be, by the way, should have z here, should be z, not like that, should have z here, so should be z, and we should have w here, so it should be w there. So we can have f x y, that should be z. You can have that. You can have, let's say, f x y z, let's say, is equal 2x z minus y. We can have that. And what else are the examples of the functions with the three variables? We can have, let's say, g of x, let's say, y, let's say, h. That can be given as, let's say, that should be sine, let's say, x, y, h. It can be that. Let's say if we have h of m, and let's say d can be given as, it should be, let's say, cos of, let's say, m minus, let's say, nd plus 6. It should be m. We can have that. And let's say if we can have something about, there should be, let's say, we can have f of, let's say, x, y, z. That can be given as, let's say, ln x plus y plus, let's say, z. We can have that. So those are the examples of the functions with three variables. We can have, let's say, we can have something about, let's say, and it should be, let's say, log 4 of, let's say, x minus y plus z, we can have that. And we have different examples of the actually functions with 3 variables. So how can you be able to evaluate the multivariable functions? So let's say we have the function, we have the univariable function given as f of x is equal to, let's say, 2x and a plus 5. In this case, we can also have, let's say, what is f of 2? We can have it as wherever there is x, we can have 2. That is 2 times 2 plus 5. That is given as 9. And how about, let's say, f of 0? We can have it as, it should be 5. And how about, let's say, f of 1? We can have it as, let's say, 7. Now the same principle can also be applied in the actually multivariable functions, in the sense that, let's say, if we have a case like this, let's say we have, something like this. We have, let's say, the function given as f of x comma y, let's say, is equal, and that should be x squared, and times y divided by, and that should be 2x minus, let's say, y squared. So how should we be able to evaluate the following? Let's say we should have, let's say, f of should be 1 comma 2. So in this case, it means this is x and this is y. Wherever there is x or y, we're going to substitute with those values. So in this case, we'll have it as, 1 to the power 2 times 2, like that, divided by, so have 2 times 1 minus, that should be 2 to the power 2, like that. That will be the same as, we'll have 2 divided by, we'll have 2 minus 4. That will be given as 2 divided by negative 2. That is the same as the negative 1. How about we should have, that should be f of negative 2 and comma negative 1. How do you think we should have it? So in this case, we'll have it as negative 2 to the power 2, that should be times minus 1 divided by, that is 2 times negative 2 and the minus negative 1 to the power 2, like that, which is the same as, it should be negative 4. The divided by, what is 2 times negative 2? That is negative 4 and minus 1 in this case. So have it as negative 4 divided by negative 5, so which is the same as positive 4 over 5. So that's how you can simplify or evaluate that one. And how about if we have this? Let's say if we can have, we should have, let's say, f of x plus h and comma y. How do you think we should have this? Principle remains the same. This is the input for x, and the other one is the input for y. So in this case, we'll have it as, x plus h to the power 2 and the times y. So in this case, divide by 2 times x plus h and the minus y to the power 2. So you can just have to expand that side. Upon expanding, we'll have it as x plus x squared plus, by the way, we should have to have it properly. So in this case, this is the same as x plus h and it times x plus h and times y outside. So in this case, divided by, that is 2x, plus 2y and minus y squared, like that. So we should have to expand there. Upon expanding, we'll distribute y. That will be the way out. Now how about, let's say, if we have something like this, and let's see how you can have that. Let's say if we have the function which is given as, let's say, g of x comma y, which is equal to, let's say, should be x sine of, that should be sine of y plus the sine of x. So how do you think we should have to evaluate the following? Let's say if we have g of, and that should be pi over 0, should be pi, or actually pi comma 0. How should you have this? Principle remains the same. That will be given as, g of pi of 0, actually g of pi comma 0, that is given as, so half pi, that is the sine of 0 plus, should be sine of pi. So how do you think is the value of sine 0? Sine 0 is the same as 0. So in this case, we have 0 times pi, that is given as 0, and plus. And how about the sine of, should be the value of pi. So pi is the same as 180 degrees. So sine 180 is the same as 0. So hence we have the overall being given as 0. And how about if we can have, let's say, g of pi over 2, and that should be comma pi over 4. So how do you think we should have this? So you should have to understand about, the spatial angles as well as the concept behind the unit circle, because those are the things that are being used here. So the aspects of, let's say, 270 degrees, 180, 90 degrees, and even 0 degrees as well. And apart from that, you should know about the whole aspect of the unit circle and the angle measurements. Those are the things that are very necessary in the context of the trigonometric functions. So in this case, we have it as has to be pi over 2. It should be this. Has to be g of pi over 2, and pi over 4, that is the same as, so what is we have pi over 2 as x, sine, what is the y, we have pi over 4, and plus we have pi over 2, like that. So what is pi over 2? Pi over 2 is the same as 90 degrees. So what is the sine of 90 degrees? We have it as 1. So have pi over 4, actually should be 2 times 1, and should be plus. What is the sine of, what is, by the way, this is not as 90 degrees. That is 45. So what is the sine of angle 45 degrees? That is the same as, should be 1 over root 2. So it is the same as 1 over root 2. That is the value of, should be sine over 4. And plus, what is the sine of pi over 4? That is, should be over 2. That is 90. So sine 90 is the same as 1. We'll have that one as that. So in this case, we'll have it as, pi over, we have 2 times the square of 2 and plus 1. Then you can proceed it from there. And using the same function, try to evaluate the following. So that is, we have, let's say, c. So let's say c is given as, should be, let's say, g of should be x comma y plus, there should be h, like that. Now, what if we have the function given as this? Let's say we have the function, given as, should be f of x, y, z. Let's say it is given as square of y minus, square of, should be x minus 2z. So we should have to evaluate the following. So try to evaluate, let's say, f of, that should be 3, 4, and 1. We should also have to evaluate, let's say, f of, that should be f of, let's say, 10, 0, 0. How should you have it? And what if we have, let's say, the function, which is given as, let's say we have a function f of xy. Let's say it is given as x squared, ln of, and that should be x plus y. So how do you think we can have to evaluate the following with respect to the function? Let's say we have f of 3, 1 can be that. So how can you have that? And also we should have something about, let's say, f of, that should be 0, should be f of 1, should be comma e. How should you have that one? So try to express that. And let's say if we have something about, let's say, if we have the function f of x, y as well as they said, which is equal to, we should have it as, we just have to clear out these things. So in this case, so let's say we have the function f of x, y, z, being given as, should be ln of z minus, let's say we have the square root of, x squared plus y squared. So how should you have to evaluate the following? So that is f of, should be 4 comma negative 3 comma 6, and we should have, let's say, f of should be that of 5, 0, 1. So that's how you should have to understand about the multivariable functions and how we can be able to evaluate them.